So now in question number 19 he is asking two blocks of same metal having the same mass at the temperature T1 and T2 respectively are brought in contact with each other and allowed to attain a thermal equilibrium. At the constant pressure, the change in the entropy delta S for this process is. Now first I want to clear that when thermal equilibrium is achieved, then the temperature of both of the blocks will become same, right? Let's move on to the solution of this question. The solution will be, now we know that the change in entropy delta S is equal to Cp ln T final upon T initial, right? So this is the formula of the entropy change when temperature is changing. Now initial temperature for the block 1, initial temperatures block 1, that is T1, and the block 2, that is T2. Let us assume that, assuming T2 is greater than T1. Now, since they are coming in the thermal equilibrium, the final temperature, I should say, the final temperature for both the blocks will be T1 plus T2 by 2, right? So the initial temperature of block 1 was T1 and the final is T1 plus T1 by 2, and second is T2 and final will be T1 plus T2 by 2. Let's find out the entropy change for the first block. So delta S1, you can say, it will be equal to Cp ln, the final temperature is T1 plus T2 whole divided by 2 divided by T1, right? So this is our first equation, you can say, and delta S2 for the second block, Cp ln T1 plus T2 whole divided by 2 upon T2. This is the equation number 2. The total entropy change will be equal to delta S1 plus delta S2, and if we solve for that, that is equal to Cp ln T1 plus T2 by twice of T1, this is for the block 1, right, plus Cp ln T1 plus T2 whole divided by 2 T2, right? Taking Cp common, we know that log A plus log B is equal to log A into B, then it will be ln T1 plus T2 multiplied by T1 plus T2 divided by 4 T1 into T2, and solving it further, it will be Cp ln T1 plus T2 upon 4 T1 into T2 whole square. So this is the final answer, and the option will be second. That will be the correct option, right? Let's move on to the next question. Question number 20. The correct statement among A to D regarding hydrogen as a fuel. It produces less pollutants than petrol. Definitely hydrogen will burn and it will form water. Cylinder of compressed dihydrogen weighs 30 times more than that of petrol tank, producing the same amount of energy. The calorific value of hydrogen is very high, that's why it is a correct option. Dihydrogen is stored in the tank of the metal alloys like NaNi5. Hydrogen is very explosive, it is very difficult to handle hydrogen as a fuel, that's why it is stored in the tanks of the metal alloys like NaNi5. On combustion, the values of energy released per gram, means the calorific value of liquid hydrogen and LPG, are 20 and 142 kilojoule respectively. This is not correct. Why? Because here he is saying that dihydrogen is giving only 50 kilojoule per gram and LPG is giving more than that. So that is not the correct option. That's why the correct options are A, B, C, and our correct option in this question is option number 4. So the answer is 4, right? Let's move on to the next question. Now, question number 21. The element that usually not show the variable oxidation state. Now, copper, titanium and vanadium, they show the variable oxidation state, they are the transition metals. Scandium, it shows only +3 oxidation state, that's why it is our correct answer. So answer is 4th, right? Let's move on to the next question.